our lecture videos. Previously, we looked at how to describe the data using some statistical measures. Having done that, we can look at another form of quantitative analysis. That is to look at the relationship that exists between our data. Now, this relationship has two forms. We can look at the correlation and the regression. Linear correlation, linear regression. There are other forms of relationship. It can be logistic, it can be nonlinear, and so on and so forth. But our focus will be on the linear relationship that exists between two or more variables. Correlation, here we said that is to give a if I draw a scatter plot, I can view correlation in a scatter plot. I have my x and then my y. One key important thing on the correlation is that x can correlate with y implies or it is equal to y correlating with x. So I'm not so cautious of what is my independent variable, what is my dependent variable. No. Which one is the cause, which one is the effect? No. As far as they are correlating, it means that they move in a parallel position. So whichever position any one of these variables takes, I'm not in trouble. Now there's a correlation coefficient. If you can't use a scatter plot to see the trend, you can find the correlation coefficient. So let me just extend the sheet. Coefficient, that is the numerical value. We mostly denote it as R. Now R can be between -1 and then 1. It can move to this direction, it can move to that direction, it can be on the 0. How do you describe this relationship? That is the third one. If it's 0, it means there's no correlation. There's no movement between these two variables. If it is 1, there's a strong, it is positive. If it's -1, we say there's a negative correlation. There's another way to describe this positive and negative. You can look at it being strong and it being weak. Strong is when you have from 0.5 through to the strong heading towards 1 or approaching 1. And it can be strong negative if it's also approaching 1. So if I have, let's say, 0.9, R equal to 0.9, this is a strong positive correlation. If I have R equal to -0.89, this is a strong negative correlation. So it means that if one increases, the other one is in the opposite direction. If it's positive, it means that as one increases, the other increases. They are positively related. Rise in one causes a rise. Negative is like an inverse relationship. Rise in one causes a fall in the other. So that's for correlation. Now let's look at the regression analysis. For regression, I can't commit this crime. Find the regression between x and y. It's not the same as find the regression between y and then x. This because under regression, I need to specify which one is my dependent variable and which one is my independent variable. My dependent variable becomes the effect, and then the independent is the cause. It means one causes the other. This can also be called as the response variable, and this as the cause variable or explanatory variable. It is explaining the dependent variable. There are so many names, so this is the same as independent and cause, effect, and all that. There are so many names to come across, but when you get the names, relax, think through and understand why they have those names. So it means that if I say x affects y, I don't expect it to be the same as y affecting x. Unlike correlation, this holds. Regression, you need to specify. Regression is also a model. It means that if I go back to my scatter plot here, so let me do away with this. If I can draw a line through the scatter plot, it means I'm looking at the line of the equation of the line, which is a model. Mostly in Excel uses y to be the dependent variable, and then it uses x to be the independent variable. So when you open your Excel sheet, it will request for x and y. You must know what they mean. So if I'm writing my regression model, I have y is equal to some coefficient and then the dependencies of x. If it's more than two independent variables, you know I have my coefficients here, beta 1 x1, beta 2 x2, through to beta n xn. All these needs to be known. These coefficients need to be known. If they are known, then I can have a table. Let me change the ink. I can have a table that will have the x values. I can have the predicted values. I can have the original values, and I can find the error. The error margin becomes the difference between the predicted and the actual values, or the residuals. So y hat is the predicted value from the regression model. So there's a regression model. Now how do I use my Excel to obtain this model? So let's move straight to the same data. Now you have to reason around this. Ticket and profit, which one depends on the other? You can argue out your own statement if it's not provided, but I believe that the number of tickets sold would my profit depends on the number of tickets sold. So the number of tickets sold has effect on the profit margin. So I'm assuming my profit to be the dependent variable, and then I'm assuming my tickets sold to be the independent variable. Okay, so dependent in Excel takes the y, and then the independent in Excel takes the x. Alright, so how do we do this? If I select this whole data, I go back to the same data analysis, statistics, but let's say correlation first. It means I don't come back to descriptive, I move to correlation here. I expect just a value. Where do I place the answer? Please place it in the cell. So I click an empty cell. It is grouped by columns. Yes. Okay. So there's my correlation coefficient value. So column 1 is my tickets sold. Don't forget, correlation is irrespective of whichever is your x and whichever is your y. Tickets sold. And then my column 2 is my profit. This header should have picked up, but I'm not so sure why it's not working. So how would you describe this 0.87? It is strong, it is positive correlation. It means that if I have high number of tickets sold, I can make more profit. Okay, so that's how you interpret your correlation. Let's look at regression. I will select the same data. I move to the statistics, but I don't select correlation. I go to regression. You must be careful here. It's asking for the independent variables as x. It has picked my first column. Luckily for me, that is indeed my first independent variable, so I'm good to go. Dependent variable, it has picked the second column. If this is not the case, it means you must provide the right columns. Don't forget that. Excel will pick the first and second as your x and y, but I told you you must select or predict. The word predict is not correct. You must know which of them is your dependent and which of them is your independent. It says both x and y has range values, labels, which is yes. Results to, where do we place this result? Let it be here. It is grouped by columns, yes. The output regression type, I told you we are using linear. You can play around these other types and see the output. The confidence interval 95% with already explained this in class. Do you want your residuals to be calculated? It means a table. I want it to be done, so yes, and I click OK. Let's see what we have. There are some key things you must explain. You must be able to explain this one. You must be able to explain your adjusted R square. We have the coefficients here. This is what we need. I think the green is not helping. Let me use this. We have our p-values here. It has its own information. Now this is my table. So my x here is the first column, the ticket sold. That is my independent variable. Predicted y is my y hat here, which is in my Excel this whole column. My y is the actual profit, which is this column. The error margin here is what I have here. And so that is it. So how do we write the model? From what I have in my Excel sheet, my y can be equal to beta naught is the intercept, negative 0.882, and then plus the ticket, so beta 1 is 0.007x. If you don't use y and x, you can use the profit p is equal to 0.882 plus 0.07 ticket sold t. So it used this model to give us a predicted y. That is what it did. So let's see the first one. If you want to know the profit margin for the first one, negative 0.822 plus negative 0.882 plus 0.007. The first ticket is 492. I mean, this should give you an answer of 2.987 from the table. My pen is not helping at the moment, but I hope you get the explanation. So this is it for regression, and that is how you write the simple model. If it's two independent variables, you go with the same approach and then you get it. Now, what is the adjusted R square and R square does imply? Kindly take note of this and interpret your results accordingly. It might vary from analysis to analysis, but you know, is the interpretation still the same? You want to know how much of the independent variable is explained in the dependent variable. How much is the ticket sold affected by the profit margin? So we know R squared to be that. It means that R is a square root of that. That gives you correlation. You can verify that the square root of this should give you 0.87. You can do that. Okay, and then is the model significant? That depends on your p-value here against your confidence interval 0.95. How do you interpret it? If your p-value is less than the confidence interval, you know that it is good. If not, you have to check something out. So is this model significant? That's a question to answer, and I hope you can take your time and then play around this correlation and regression. Try to explain them. We'll meet in the next sessions.